All right, in this lesson, we are going to be discussing similar solids. And to start with, we're going to try to show or find some relationships between similar solids. Now, we know that similar figures have proportional parts or proportional lengths. So as we look at this, we're going to look at the ratios of the smaller rectangular prism over the larger rectangular prism. And we'll just go right ahead and start with the lengths, because the length also gives us our scale factor. So remember, that's called the scale factor, and we are going to go ahead and look at these two rectangular prisms to find the scale factor. Since we know they're similar, we can just do one of the corresponding parts. So let's go ahead and look at the smaller rectangular prism. You have a 6 there on the bottom segment. So 6 compared to the larger one, 15. And we know when we do ratios, we should reduce them. So both of these can be reduced by 3, and we get 2 over 5. So that is the ratio of lengths. That is our scale factor. Now what we're going to do is we're going to look at the ratio of the areas. We could do ratio of just the faces, the individual faces, which would be fine. In fact, let's go ahead and do that. Let's look at the front face of the smaller one. That would be a 6x4 rectangle. So that would be, its area would be 24. And then the front of the larger one, the front face is 15 times 10, so that would be 150. And both of those can be reduced. 3 goes into 24 8 times, and 3 goes into 150 50 times. And then we notice that, well, 2 can go into both of those. So 2 goes into that 4 times, and 2 goes into this 25 times. So that's the ratio of the face, the front face. We also have the ratio of the surface areas, which actually is shown to us here. So we have the surface area of the smaller one is 108 units cubed. So still under area, but this is 108. And the surface area of the larger one is 675. Well, we want to reduce those also. I think 9 goes into both of these. So if you divide this, 108 divided by 9 is 12. Oops, I don't want to write 9 there. So 108 divided by 9 is 12. 675, if you figure that out, 675 divided by 9 is 75. And then we can reduce a little bit more. 3 goes into both of these. 3 goes into this 4 times, and 3 goes into this 25 times. So we actually get the same ratio. So that's one thing we can notice. But we also, if we were to try to relate this back to our scale factor or our ratio of lengths, we see that 4 is actually 2 squared, and 25 is 5 squared. So we see that the ratio, so this is important, the ratio of the areas, whether it's a surface area or just an area of one of the faces, is going to be the ratio of the lengths squared. So the ratio of the lengths squared. Well, and that has to do with area is square units, so it has to do with squares. So you might be able to take a guess of what's going to happen with the volume, but let's go ahead and look at that. So we'll get rid of our total surface area there. Let's show the volume. We could find the volume of this by multiplying out, but they haven't figured it out for us. So the volume of the smaller one is 72 units cubed, and the volume of the larger one is 1,125 units cubed. Now, both of these are divisible by 9. So if we divide 72 by 9, we get 8. And if you figure out what 1,125 divided by 9 is, you actually get 125. And relating back to our ratio of lengths here, or the scale factor, we can realize that 8 is 2 cubed and 125 is 5 cubed. So we have these relationships. We have our relationships of lengths is just the scale factor. Relationship of areas is the scale factor or the ratio of lengths squared, square the top, square the bottom. And volumes is the scale factor cubed. Now I also want you to realize if you have the ratio of the areas and you want the ratio of the lengths, you can take the square root of that. So we can take the square root of the top over the square root of the bottom. And similarly, if we want to get to the ratio of the lengths from the volumes, you can take the cubed root of the top over the cubed root of the bottom, and that will get you back to the scale factor, which is also the ratio of the lengths.